So, hi all. Hi guys, I am Preprocessing and I have been taking MLP sessions this term, and I also have MLP and MLP project, right? But I know machine learning from you can say like from 2 years, so I know like most of the course content covered in MLP course. So just like to help you all, I'm taking the ML sessions and uh, like as we are moving forward, we have cleared the quiz one, and now OPP1 is coming, which is a online programming exam, proctored programming exam. So today we have the OPP1 revision session. So we will like do two revision sessions for the OPP1. First, which is today, and second is maybe Friday or Saturday. Today we will cover mainly like the complete concepts from week 1 to week 5, which is the syllabus for OPP. If you have any doubt in any of the concepts from week 1 to week 5, I'll list all the concepts, all right? And if you have any doubts, you can just ask and we will cover that one. And after that, uh, we will do the mock OPP, which we have received in our dashboard, which are like these two, OPP1 mock and OPP1 one mock part 2. And by this, like, this is for the today's revision session, and in second revision session we will do the NPP, also the PYQs for MLP. So this is how like we will do the revision for OPP. And if you have anything else that we can cover in the revision sessions, you can obviously speak up and tell, so we will include those things also. So let's start. Okay, just before starting, for the recording of my session, you can get it via YouTube in my channel. I'll upload the recording after the session. So this is my YouTube channel. Just type Param Pitching or Param 3021, and you can subscribe to it for the recording. All right, for this video. Okay, so let's start. The VS Code is visible, right? And the font size.
Yes.
Okay. And just one thing, this is a interactive session, and this is like I am also a student, so don't like if you ever feel the session is getting bored or something like that, you can speak up or you can interrupt me in between even if you have any doubts. Don't consider it as a like a lecture or something like that. All right. So
Excuse me.
yes.
Excuse me. Are you going to just cover? I mean, are you going to cover some of the topics from Python programming as well, or is it just for machine learning?
No, it is for machine learning only. But yeah, we do have Numpy and Pandas. So of course, if anybody has any doubt in Numpy or Pandas, we will cover that one. For the Python, like if you have Python subject, as I said in the Python group, I will do the Python OPP1 revision session also. Okay.
I
Uh,
mean, when you'll be, are you going to post it on the mail itself, or I mean, when it will
yeah.
when it will be happening?
Okay. So I think Thursday maybe. I have done the poll. I'll announce the final date and timings in the group by like end of today. All right.
And will you also post it on the mail itself also?
Yes. Most
Actually, I
probably.
got it through
So,
mail only. I mean,
yeah, it's a humble request to kindly post it on mail, please.
Yeah.
Yeah, I'll
Yes.
forward the mail. Do not worry. We can begin with the session today. And rest of the doubts,
thank you so much.
especially regarding mail and other links, you can ask in the chat box. I'll answer that.
Hmm. Like all of my sessions are now collaborated with the GIR House, which is one of the 12 houses of IIT Madras BS degree. And Vignesh Mishra, he is the secretary of GIR House, and he will forward the mail. He will forward the like session details with you all via mail. All right. And just one thing, like if you want to keep the track of the sessions, okay, okay. This is the calendar link. You can subscribe to it. Obviously, it's free. So this calendar link, you can join this calendar and turn on the sync. All right, and then you will receive all the updates regarding my upcoming sessions. Okay, so let's start. We have week 1 to week 5 in OPP1, the syllabus, and this is the roughly like thing. In week 1 we have pandas, and in week 2 we have mainly the model pipeline stuff. Okay, the complete end-to-end machine learning workflow. Then in week 3 we have like data pre-processing in detail, in which we cover the missing values, encoders, the transformation, scaling, and feature selection. All right, and then in week 4 we have the linear regression as well as the SJD regression, which is the linear regression itself, just in another variant. And then we have in week 5 regularization mainly for the linear regression, also like the hyperparameter tuning and cross validation. So these are all the like topics, okay, from week 1 to week 5, and these topics I have listed here in detail, which we have. And if you have like any of, if you have any doubt in any of the topics listed, you can simply ask, or any function in pandas or scikit-learn, you can ask and we will clear it up. All right, so numpy, is there anybody has any doubt in numpy or pandas? You guys can speak up, raise your hand, or type in the chat box. um, okay, if nobody has any doubt, just give me a thumbs up so like we can move on. Okay, then these are the like the main libraries, you can say the main APIs which is being used from week 1 to week 5. Then in data pre-processing, the main thing is data cleaning, and data cleaning is simply handling the missing values, either missing values and outliers as well, either by removing them or replacing them with some other value. So we have mainly two things, SimpleImputer and KNN-imputer for the missing values. So are you guys clear with both of these concepts? Both of these, mainly the strategies. Okay. Then in feature engineering is mainly depends upon us how do we do it. Then we have like some special thing, which is the polynomial features, and there we have like several parameters, also interaction only, and as well as the intercept. So do you guys have like, are you guys clear with the concept of feature engineering completely? um, if you have
And
any
not very clear.
okay, so let me just directly show you. Let me create a sample data frame. Is the font size clear?
Yes, it is fine.
Okay, so I'm just creating a sample data frame. Okay, pd.data frame, and here I'll have, let's say, uh, two key value pairs. First is name, Arun, Arun, and let's say image, and then we have another parameter, let's say marks, which is another column, and any marks, 56, 78, 77, 89. Okay, so 4. All right. And then in the polynomial features, let's say I'll add extra feature. You can simply write it as okay. Okay, this marks. Let's like forget this marks feature as of now. I'll simply write two features for the simplicity. 1, 2, 3, 4, and x2 as 2, 3, 4, 5. Okay. So this is the data frame we have. Okay. Yeah. PD. Okay. So this is the data frame we have. Okay, we have three features. First is name, second is x1, and third is x2. Okay, then what does the polynomial features mainly do is it create the polynomial features up to some nth degree from the existing features. Okay, so how let me just first import it from Sklearn dot, I think it was in features, preprocessing. Yeah, preprocessing import polynomial feature. So I have imported the polynomial features here. So what I'll do is, if I simply write a question mark before it and run it, you can see this is the signature of, you can say, this is how the complete documentation of the polynomial features. So the polynomial features, we call it some, whenever we call it, we have these many parameters. First is degree, then interaction only, then include bias, and some order C, and we have other parameters also. So these are some example. Let me show you how it works. So I'll simply create a poly name variable and I'll just normally call it. And okay, so I have created a polynomial features class and instance, and then we will uh, transform these x1 and x2 features uh, like using this polynomial features. Okay, so to transform, I'll use the fit transform method, and I'll pass okay, the df directly with x1 and x2. Now if I run it, you can see I have passed only two columns. If I simply run this cell, this code, I have passed these two features only, and I have received like in return I got a total of three, three and three, six features. All right. So how do we like got these features? So the first thing, which is, okay, if I let me open the whiteboard. Just give me a second. Let me attach. So normally what polynomial features do is, okay, I am simply writing pf. By default the degree is 2. Okay, what do you mean by degree is 2? Like I have two features, x1 and x2. I'm not writing the values as of now. By default, if I run polynomial features on both of these features, I get like you can see here, you can see I get 6 features as the output. The first feature is the okay, the first feature is the direct the x1 itself, then the second feature. Okay, after these features I get the, yeah, okay, after these features I get the a constant value, which you can simply say 1 or something like that. Okay, then we have like two more, then we get the possible combinations with the maximum degree of 2. Okay, sorry, not the maximum, with the only degree 2. So for the x1 we will get the x1 square, then for the x2 we get the x2 square, then we get another feature which is x1 into x2. This also has 2 degree, one is this and one for this, and the degrees are added if the features are multiplying. So this is all the like 6 columns we are getting. Okay, so here you can, if you can see, we have passed this 1 2 3 4 and 2 3 4 5, these two features, and First, like, okay, the first column itself is the constant column, which is this, okay, and then we have these two columns itself, x1 and x2, and then we have the x1 square, and then we have the okay, yeah, so then we have the x1 and x2, and then we have x2 square. So these are all the features we got. This is mainly what a polynomial transformation is, okay. This is for the degree 2. Degree 2 means the only we get the features which we had earlier, and then we have these features with the degree 2. So if I set degree equals to 3, we get, the features will be increased, obviously, the number of features, and so on and so forth. Now there are mainly two parameters in polynomial features. First one is the degree itself, okay, 2 or 3 or anything, and then we have the include bias term. But this include bias is by default it is true, okay. So this represent this constant value. If I set it to false, then I won't get this first column here, okay. This first column I won't get. Let me show you. Include bias equals false, and now if I run it, you can see I got only 5 columns. And okay, there is one more important, like, there is one more important parameter, which is interaction only, okay. So interaction only is basically the interaction between the variables, okay. By default it is false. Like interaction only here represent the interaction between the variables which is happening. So the interaction is happening here only. So we get, if I set it to true, I'll get only this feature in my transform dataset, as well as like these three also. But we won't get these two features because I have set interaction only as true. So this is the purpose of setting interaction only true. Sometimes we only need the interaction values only, not the complete degree, not a complete features. If I set it to true, and then you can see I have the first two columns as it is, x1 and x2. Then I have this column which is the interaction column, like x1 into x2. So 1 into 2, 2, 2 into 3, 6, and so on and so forth. So this is how polynomial transformation works. Is this clear?
Hello,
Okay.
I am audible.
Yes.
Yeah, I have a small query. Like, can you please share the screen like that? So, in include bias, it is only removing first column, right? In which only one values was there.
Right.
So it will only exclude only that one column in which only one values are present, not others.
Right. Right. Bias is this simply one column extra, extra column which we are getting. Okay.
Okay, okay, okay.
So
And its order will be remain same, like, or it may be different. It can vary. Like
uh,
first column will be x1, another column will be x2. Then after that x1 square.
the
After that
order
x2
will be
square.
universal. Like the order will be universal for all the data sets. The first column is the constant column. Okay, the one,
Okay,
and then we have the x1, x2. Okay, let me write these in the order. So first we will get one. Then the exact features which we have, like up to xn. Okay. Then we get the x1 to xn up to the degree, whichever. Okay, not the degree exactly, but okay. Then we have, like, let's say we have the degree 2, so x1 square, then we have x1 into x2, then we have x2 square. Okay, so it goes via like this. And if we have x3 also, x cube also, then this degree will be transformed to 3, and this will be shifted to the next column. Mainly you don't need to remember the, like, order, okay. So that doesn't matter. Order mainly doesn't matter in the columns, because all columns are mainly, we can say, independent of each other. For the machine learning obviously the columns are independent, so of course it's nothing to worry about. Yes, I'm recording this session and it will be uploaded on my YouTube channel. Okay,
Parampreet,
so
I have a query.
mhm,
Can you show me that where you are coding? If we remove this this thing,
mhm.
interaction only for false, and we okay, we include the bias thing, remove the bias thing.
Okay,
So, but the
include bias false.
yeah, no, second term that you wrote, no, second term that you wrote, interaction one,
Okay, let me set it. Interaction only and true.
right? So one will come. That's what I wanted to know.
Yeah, because
Yeah.
okay, this column, the first column is handled by this parameter include bias. By default, it is true, and interaction only by default it is false because it is like interaction only. So if we set it to true, then we will get this column only. Okay, not these two columns. So this is why it is happening.
Yeah. Okay, thank you so much.
Okay.
Can you also write this thing as markdown just below the
Yeah, I will
code?
like when I after the session, I'll add the documentation, okay, in the notebook and I'll share the
Yeah,
notebook.
that works.
Okay. So yeah, this is all about the polynomial transformation. Is it clear to you all?
Yes. How exactly do you think we'll have questions related to polynomial transformation
Okay,
in OPP?
we will have mainly a model pipeline, okay, similar to the questions we have in PA and GA. We get a comprehensive kind of questions. The first, like, we are supposed to handle the missing values with a pipeline or a transformer, and then we have to add a step, let's say polynomial features, and we have to do the polynomial features on certain columns, and that you can handle by a column transformer. All right. So
Clear.
yeah. This is about the feature engineering. Then in feature transformation, we mainly have the encoders to transform the categorical features into numerical features. So we have these three encoders. Is this clear to you all? These are like very basic ones. Nothing much. There are more uh, encoders also, uh, but mainly these are used, so that's why I have included this. Then we have the feature selection. So these are all the different techniques for the feature selection. Uh, some are like wrapper based. Basically, they use a model, uh, and some are mainly direct the feature selection techniques, where we just have to pass the data itself. Yes. No need to raise your hand. You can directly speak up. Okay. So like these three are the direct feature selection methods, a mutual information variance threshold and the chi-square. Variance threshold, here we have to pass a threshold value, and these are like the wrapper based methods. We have to like pass a model or the feature selection technique. Okay, and then we have this feature scaling. So we have various techniques. Some majorly used techniques are listed here: the standard scaler, which is z-score normalization, and then min-max scaler and max ABS scaler. Are these clear to you all?
Can you actually show the working of these three?
Okay. So we have first standard scaler. Then we have min-max scaler. Okay. Then we have max ABS scaler. So okay, the working mainly, right? Working I'll directly show with the code. Let's take only these two columns. All right. Let me import these techniques first. standard scalar, min-max scalar, and then max ABS scalar. So these three techniques I have imported here. Similar to the polynomial features, I have to create their instance and then I have to apply the fit transform method. So let me write std scalar, and this is the standard scalar, and standard scalar dot fit transform, and I'll simply pass this data set. Okay, now this is the data which we got in return. How it is working, it is using this formula. Standard scalar is using this formula. For each data point, we are subtracting the mean of that specific column, like this is for a one column only, okay, and dividing it by the standard deviation. So like the first feature which we have here, 1 2 3 4, it is taking the mean of this feature and subtracting the mean from each value and then dividing it by the standard deviation of that specific column. This is how standard scalar is working. Now for the min-max scalar, the same way, like I'll simply write the min scalar and min-max scalar, and here I'll simply call the fit transform method. So this is the same data set I have passed, and yeah, min-max scalar have a range. So this is the transform data set we got by min-max scalar. Min-max formula of min-max scalar is like for it subtracts the minimum value from each data point of a column, and also it divides the difference between the maximum value of that specific column via by minimum value. Okay, so this is the formula for min-max scalar, and its range is 0 to 1. So whenever, like let's suppose in the OPP they have asked you to transform the data set in such a way you get the values in the range of 0 to 1, then you have to use the min-max scalar only, right? The standard scalar doesn't give you the values in the range of 0 to 1. It gives you in the range of, like you can say, minus standard deviation to plus standard deviation or something like that, but it is not about there is no specific range for the standard scalar, but we have for the min-max scalar. And then the third one, which is max ABS scalar, I'll simply, okay, let me write it here, max ABS scalar. So this is, okay, max ABS, this is the max ABS scalar, and I simply have to do the same thing, which is I have to call the fit transform, and here I'm passing the same data set and I'm getting the values like this. Now okay, let me show you the formula for it. For the max ABS, it divides each data point via the maximum absolute value. Like it first take the absolute of the specific column, okay, then we get all the values in positive, and then it takes the maximum value and it divides each data point via their maximum absolute value. So this is what max ABS scalar do. So is this clear to you all? If you have any doubt, you can ask. Okay. Yeah. One more thing. They may ask you like to apply the z-score transformation or something like that. Okay. So the z-score normalization. This is another name for the standard scalar. Okay. Standard scalar and z-score normalization both are same thing. These are just different names. Okay.
My question is that this fit transform,
Mm-hmm.
is it used for just the scalars or at other places too?
No. Fit transform is mostly like it is the universal method for all the transformers in scikit-learn. Like for the polynomial features also, for the encoders also, we have like we use this fit transform. In fact, for some of the feature selection techniques also, we use the same thing. And the data cleaning ways, which are SimpleImputer and Imputer, we use the fit transform. So these methods are universal. Fit fit transform and transform. And make sure like whenever you are using any of these features, okay, any of these things, transformers or anything, you call the fit transform on training dataset, and on the validation or test dataset you only call the transform method, okay, not the fit transform. Then you might get, then you will get obviously different values, which is
What
not
is the difference between the two?
okay. We have like three features mainly, okay. Fit underscore transform, and then transform. Okay, let me like give them the number. So 1 2 3. Fit basically compute the values whichever we need to compute. Like for the standard scalar, it will we will pass on the data and it will compute the standard deviation and mean value. Okay, it just compute. It doesn't do anything else. Then fit underscore transform, it will compute as well as transform. Okay, compute and transform, and the transform, it just simply transform the values. So um,
So
okay,
why
are
should
you
we not
still?
fit on that fit
Yeah,
on?
just chilling. Shankar, you have any doubt?
Yeah, so whatever questions we get in OPPE, apart from that, will they also tell us to do something else and we get marks basis on that also, or the questions
I
which
think
we
no,
got on?
no. We have to do the mainly these two things. First
So,
is data pre-processing, and second is the modeling, which is obviously in the syllabus of OPP.
so our marks will be calculated based on that only, right?
Right.
Okay, thank
Okay.
you.
Yeah. So, the first main thing is these three methods. So, let me like just tell you the difference. Fit basically compute the values. Let's say, let's take the example of standard scalar only. So, for the standard scalar, it will compute the mean value. Okay, if we pass on the data set as well as the standard deviation, which is the sigma, which we need to denote the standard deviation. Okay, and then we have the transform basically transform the we pass on the data set and it transform the data set using these two values. Okay, and then fit transform, it computes the value as well as it transform. Okay, so basically fit transform is calling 1 and 3 together, right? The first function and the third function call, if we call them together we get the same output as if we call the only the fit transform. So like why we should not use the fit transform on test data set? Because on the based, let's say you are handling the missing values, okay, and you are simply using the mean strategy. You have a data set of let's say 30 rows, and for a feature x1 you got the mean value as let's say 20. Okay, and in the 30 rows there are some let's say 5 to 6 missing values and you have imputed them via 20. Okay, then on the test set you got only let's suppose say one sample. Okay, uh, in machine learning competitions and in the like normal general practice of machine learning, we have a test set which is having like at least let's say 100 to 200 samples. So this isn't the case in actual scenario, in real scenario. Let's say you have deployed the model somewhere, okay, and there obviously the end user doesn't, like the end user do the call the model basically for the predictions once by once, like for each sample. Then you get only like let's say you got only one test sample, and you have to like there the feature x1 is missing. Okay, the value of the x1 feature is missing, then you have to impute it. And if you call fit here, you will get an error, like there is no existing value for the x1 feature, um, like on the basis of what you will compute these two values or some other value, let's say mean here. Okay, so that's why we call the transform. This is one reason. Another reason is like हमें जो है we have to do everything based upon the training data. We train the model on training data and we do the predictions and validation on test data. The same thing we do in the data pre-processing. We like do the data pre-processing on the training data itself. Okay. So that's why we call the fit or fit transform on training data, and then we do the like rest of the transformation only on the test or validation data set. Because obviously this is you don't need to like if you call the fit transform on test or validation dataset, there is a concept called data leakage, and that will happen, like the data will be leaked. Week 5 YouTube link is not found. Okay, um, I'm not clear what you are talking about. Yeah, so this is the main difference between fit transform and transform. Is this clear now? All right, so yeah, then we have like after the feature scaling we have this model pipeline, the first pipeline itself and the feature union and the column transformer. These two are mainly the same things, like transform the do the pipeline or the transformation stuff in parallel and then combine those features and return it. And the pipeline, this is, you can say, the most important thing which you should learn, okay, for the general purpose also as well as for the OPP, because in OPP they will ask you to create multiple pipelines and do the transformation on them directly. Then we have this our first machine learning model, which is linear regression. In linear regression we have various variants. First is the simple linear regression, then the uh, multivariate or multiple linear regression. Simple linear regression is for just for one feature data set. Okay, and if we simply remove the simple, we get the original linear regression, which is for the multiple features. Generally we have multiple features, so that's why we use linear regression directly. Then linear regression has like two variants. We can like do the same thing, like find the weights in linear regression via two ways. The first one is the normal equation method, which is basically the matrix multiplication. The second is gradient descent way. There here we have to like compute the derivatives for the like cost function, and we have to update the weight values and the bias terms based upon the derivatives. And then we have like two more you can say variants for linear regression. These are basically regularization. So ridge and lasso. Regularization is are you all like clear with the concept of regularization? Mainly all these four. um, okay, if you have any doubt in anyone, you can simply ask.
Can you please show one of them, working of one of them?
Okay, working. Simply okay. From Sklearn dot linear model. In linear model itself, in this linear model API, we have all these things. Okay. I'll simply like start with the basic linear regression only. So I have imported the linear regression here. What I'll do is I'll create my model here. I'll instantiate it, linear regression, and I'll simply write model.fit, and there I'll pass the data set. So I'm passing only these two features, first two features only, and as well as some y value. Let's say y values. Okay, I have to pass it as a like numpy array. So okay, let me create a regression data set. That will be better from Sklearn data sets. Regression. So I'm just creating a sample data set. Make regression. Samples are 100 features. Let's say. Let's suppose feature is only one. Okay. Yeah. then noise value, let's say noise is, let's say 10 or something like that. So yeah, it's not head, I think it won't work. Yeah, okay. So here I have created a dummy data set. Rx looks something like this. This is like, okay, for all the rows, I'm just checking. Okay, it is size 1. So I'll simply take this. So this is just a sample data set. Okay, we have 100 data points. Okay, 100 samples and 1 feature. So that's why you can see this is like as a 1 column array. Okay, and if I set it to 2, then we'll get 2 features. So this is a sample data set, and here we have the y values also. So these are the y values which we mainly have to predict. So I'll simply pass on the x and y here in the model, and then we get our linear regression model, and if we can simply predict the data set, do the predictions on the test data set or anything like that. Let's say I do the predictions directly on x values only. So these are the predictions which I get. Okay, like obviously on the training data we get almost the same prediction as the y values, but there will be some difference, and that difference is called as the loss, and we compute it via a loss function. So there are various metrics, of course. So this is like how you implement one thing. Okay, the simple linear regression, and then we use the SJD regression and ridge and lasso as their like variants that will be specified on the OPPE, like on the question itself, which one you have to use. Okay, so this is the main linear regression. Okay, I don't have any test data. Let me create a test data also. So let's say I have a test data. I'm taking the last 90 features as for the test data. Okay, so I'll start from 90th. Yes, yeah. So these are like 1, 2, 3, 4, 5. Yeah. Okay. So not the 90, 89. So these are the last 10 features we have for the test set, and let me write for external. Okay. Um. Oh, let me directly split it. That would be better. Let me use the train test split from Sklearn dot model selection, and here I'll use train test split. Train test split, and the train test split will split the dataset into 2 parts: xtrain and xtest, ytrain and ytest, and I'll simply pass the data itself here, x and y, and let me set the test size as 0.2. So 80%, like first 80 samples will be on the training set, and rest 20 samples will be on the test set, and I'm setting random state to 27, so I'll get the same data whenever I call this again and again. Now if we check, this is our xtrain. Okay, how our xtrain looks like, let me simply write the shape so you will get the idea. In X, we have the shape of 100 comma 2, 100 samples and 2 features which I have passed here. Like after splitting, we get these 2 datasets, xtrain and xtest, and now I'll simply fit the model on training dataset only. Okay, so I have fitted the model, and then for the xtest, if I like for the predictions, I'll simply pass the xtest here, and these are the predictions which I got. And for calculating the score, so there is a default score function which is this model, which we call by model dot score. it basically computes the R2 score. So R2 score is basically the, you can say, the difference between the residuals and like their mean. So for the R2 score, I just have to pass my test dataset as well as of course the values by which I have to compute the R2 score. So I'm getting the R2 score as in the range as 0.83. So it is a pretty good score. Like the R2 score ranges from I think minus infinity to 1. Okay. And jitna bhi, like the more the score closer to 1, we'll get the evaluation formula. Which evaluation formula? Um, okay. Okay, from there, yeah, I'll simply write from Sklearn dot metrics, and we have various evaluation metrics. So R2, yeah, R2 score here. So I get the R2 score here, and now if I simply copy paste it, and I just have to pass the first actual values, which are the y-test, and then the predicted values. I'm simply calling the model.predict on the x test here. Okay, so these are the predicted values and these are the actual values, and if I run it, you can see I got the same values. So this is how we use a specific metric, and we can use various metrics. There are various metrics, shuffle y-test and y. What do you mean? Dave, can you speak up? Like, that will be better. Okay, no problem. Okay, so like, normally, like, if I think you are saying something like this, I'll model dot predict first and then the y test. Is it okay? See, the answer will vary. It may vary in some metrics and it will not vary in like some metrics, because of the formula underneath which we have. Okay. Like for the R2 score, it may vary, of course, because if we check the formula, R2 score formula. So, yeah. This is the formula. RSS is the sum of squares of residual. So it is basically uh, it it takes a difference for each of the value and then square it and then sum it. This is the RSS, and then the TSS. TSS is the okay, total sum of squares.
Variance of y.
Yeah. TSS is the variance of y. So if we pass in the values in different manner, so of course we will get the output in a different manner. But there are some metrics जिनका वे मेनली सेम है, सो उसमें कुछ ऐसा डिफरेंस नहीं रहेगा, लाइक द मीन स्क्वायर्ड वन, mean squared error. And if I call the mean squared error on this way, like in this way, I get this value. And if I call the mean square error in this way, like I'll first pass the model dot predict and then y test, I get the same value. Why? Because this is how uh, the cost function works. Like this is basically depends upon the implementation of cost function. I've taken 4 and tried manually by passing in different manner. Okay, so that's like आपको तब मिल सकता है when you have the data, like आपकी जो predicted values हैं and जो actual values हैं, those are same. So तब आपको मिल सकता है. There will be some difference. Okay, so कुछ difference हो सकता है. अब that at the end like depends upon the data which you are passing. Okay. Let me show you simply like one way. If I simply pass, let's say 1 2 3 4. Okay, and I'll pass 2 3 4 5 here, so I'll get this value. And if I reverse this, now you can see I'm getting like the same values. Okay, so आपने जो बोला वही same चीज़ यहाँ पे हुई. But for here I am getting the different values because obviously data बड़ा है, so I did manually in my notebook. ओके, मैनुअली भी आपने किया, सो तब भी आपको मिल सकता है. मैं वही कह रहा हूँ, लाइक जितना भी आपका डेटा बड़ा होता जाएगा ना, एंड द डिस्ट्रीब्यूशन विल चेंज, लाइक द डेटा फॉर्मेट विल चेंज, नॉट द फॉर्मेट, द डिस्ट्रीब्यूशन विल चेंज. एंड उसके बेस पे जो डिनोमिनेटर की वैल्यू है, विच इज़ लाइक द वेरिएंस ऑफ y, यू कैन से दैट विल बी लाइक डिफरेंट, एंड उसी के बेस पे यू विल गेट द आंसर. ओके, सो इसलिए आपको मिल रहा होगा. बट एज सच स्कोर सेम आना, that is mainly referencing you are like calculating the score on like few samples. So obviously जब भी हम validation भी करते हैं, we take 20 to 30% of the data. Yes, first you have to pass the actual values, then we have to pass the predicted values. Like if you see the signature of this, of all the metrics, first we have to pass the true values, which are the actual y values. Then we have to pass the predicted values. All right, so like even if in the OPP, don't pass like in the opposite manner, you may get different score, and if you submit that, then you might get like wrong answer. So that's the thing. Okay, yeah, then we have last two things. First is cross validation. Cross validation, is this clear to you all, like the concept in cross validation? Time series split is not necessary for any, yeah, for any evaluation metrics. We first have to pass the true values, then we have to pass the predicted values. Okay, are all these techniques clear for the cross validation? Like if you have any doubt in anyone, you can ask. We have some more techniques also based upon these only. The underlying concept is same, like in the stratified k-fold, and like group stratified k-fold, and so on and so forth. Okay. Then in
Can you
hyperparameter,
explain the cross validation and cross DOS dash uh, validation or cross validation? Difference
cross
between,
validation.
yeah.
Okay. So the concept of cross validation, right? Abhishek.
Yeah.
Okay. So like cross validation is mainly, right, cross validation is like evaluating your model's performance. There are like, generally what we do is when we have the data set, we divide it into two parts. First is train and second is valid. Okay, and then we do the validation, and then we train our model on this fit, and then we compute the score on the validation dataset. And this is a normal way of doing the validation. And then we have a concept of cross validation, which is simply, let's say this is a data set, like you can say these are the samples from 1 to 100. Okay, what a cross validation, let's take the example of k-fold cross validation. And in k-fold, let's set k equals 3. And what does mean like k equals to 3? It will split the data set into 3 parts. Okay, and also like let's say in k-fold cross validation, yeah, k equals to 3, that is the only thing. And what do we mean by like 3 parts? It will like first take, let's say this part it will take as a validation set, and these 2 parts it will take as the training set. Okay, then it will call the fit method on these two data, like these two parts, and call the score method on this validation part. Okay, this is like for the one. Okay, we have k equals to 3. Then again it will repeat the same process, but this time it will take the training set, this, and this is for the validation set, and this is for again for the training set. Then it will call the fit method based on these two data set, these two parts, and score on this validation set. Then again it will do the same thing. So here it will take the training set, this and this as the training set, and the last one part as the validation set. And by this, like k equals to 3, so we will get 3 scores. Okay, and we can compute the mean of the scores, and based on that, like we can see how our model is performing. So like this is how what a cross validation happens.
Yeah, in the suppose I use the cross dash val dot dash score,
Okay, cross
then
val score.
it gives a 3 value
Okay, yeah, in
in
cross val score you
yeah,
have
in this
passed
data.
like
If I
CV
use
equals
the
to 3
k
or
equal
something.
to 3, yeah,
Right, yeah, of course. CV is basically number of the cross validation steps you are doing. Like for the k fold we have this much only. Let's say like I am using any other or any technique, like by default it uses the k fold. So um, for any, let's take the example of the shuffle split. So if we use the shuffle split one, okay, shuffle split, and we set the CV equals to 3. It again do the same thing, like the shuffle split, let's say in the ratio of 7:3. So this will be in the validation and this will be in the training. This is for the CV1, and then again it will repeat for the 2, then again it will repeat for the 3. For 1 we'll get a different score, for 2 we will get the different score, and for 3 we'll get a different score. And if we are like comparing, doing the cross validation on different models, then rather than like looking at each, like we have CV equals to 3 or CV equal to 5, then like rather than looking at each of the score, we compute the mean. Okay, so that's what crosswell score dot mean like generally we do, and we check the mean values. Like the mean value give us the a brief idea like what is the score we have. So this is how crosswell score works. Okay, yeah, I have explained the k fold via the example only. Okay. Then we have the hyperparameter tuning. Is this clear to you all? Like, or do you have any doubt? Um, Hyperparameter tuning, like the concept or anything. Yes, Shankar.
Parampreet, can you share this main.py file?
Yes, I will share all
It
these topics in the group as well as in the video's description. All right.
it will be easy for us to
Right.
revise
Yeah,
topic one by one.
sure. I will share it. Don't worry. Okay. Uh,
Yeah, thank you.
is like, are all these concepts clear? Just give a thumbs up. If you have any doubt, you can simply ask, and then like we can move on to the mock.
No, please
Yeah, we
explain
can
the
move to the mock. Okay,
hyperparameter
fine.
ones in the notebook.
Okay, hyperparameter in the notebook. Okay, so let me use in the linear model. Let me use the SGD regressor because yeah, one thing, a basic, like you can say, linear regression doesn't have any hyperparameters. Okay, so don't do any, like don't do the mistake by using the linear regression and doing the hyperparameter tuning. These three has hyperparameters. Okay, region lasso has alpha, which are the lambda values mainly, and the SGD regressor has various hyperparameters. So I'll simply use this grid SGD regressor, and for the hyperparameters also, like grid search CV and randomized search CV. So I'm importing these two techniques. What I'll do is, okay, let me create a model. Okay, not the model. Okay. Let me first show you the hyperparameters in SGD regression. So in SGD regression, we have various hyperparameters like the loss function, the penalty. Maximum iteration is generally not, we do not consider it as a hyperparameter, but yeah, you can take it. And the L1 or L2 ratio and all the penalty and the alpha stuff. The learning rate is a hyperparameter, like how learning rate works and like which method it should use, and the ETA, it is the actual learning rate. So like we have various hyperparameters. Let me list them down. I'm creating a params name dictionary. Okay, the hyperparameters. I'm writing the parameter name like as a key value. So for we have a loss hyperparameter, we have a penalty also, we have alpha also. Okay, then L1 ratio, and then let's take the learn ETA 0. Yeah, ETA 0. So these are various hyperparameters we'll take. Then SGD regressor, we have like loss, basically specify which loss function should we use. So we have two mainly loss functions. One is squared error and the another one is Hubbard loss. Okay, so there are four values. Mainly we use these two. So let's take these two values. Okay, I'm just simply copying them and passing in as a list. Okay, so these are the two values, loss values, and then the penalty. Penalty is basically which regularization should we use, L1, L2, or like both. So I'm writing L1, L2, and elastic net. There is one more which is elastic net. It represents both. Okay, and alpha is the value like for the penalty, which is the lambda value. So we can set it as 1, 10. Okay, let me start from this order: 0 0.001, 0 0.1, 1, and 10. So these are the value, and L1 ratio, I can ignore this L1 ratio as of now क्योंकि बहुत ज़्यादा parameters हो जाएंगे. Then ETA, ETA, let's take 0.001, 0.01, 001, sorry, and 0.01 and 1. Okay, so these are some parameters which I have for my SGD regression. Now what I'll do is, there are like hyperparameter tuning हम manually भी कर सकते हैं, like for these four parameter, I have to create 4 nested loops and उसमें मुझे करना पड़ेगा. Rather than that, what I can do is I can use the grid search CV. Okay, grid search CV, it is basically do the hyperparameter tuning based upon all the combinations of all of them. Okay, so grid search CV I'll pass, and estimator, as an estimator I'll simply pass SGD regressor. Okay, I have to call the model. Okay, so first I have to pass the model, and then let's say it's then the parameter grid. Okay, param grid. So param grid, I can simply pass this. The dictionary we have to pass as a parameter grid, or like if we have only one value, then we can pass a list also. Then there is okay. There are various more parameters also. So CV, so we will set for the scoring. Yeah, like scoring metric, there are various scoring metrics. Let's say we will take the mean squared error, but like in the cross validation we have to take the square in a negative manner, so we use the negative neg underscore this as the prefix for the each of the scoring metric. Okay, not for all but for some of them. So neg underscore mean squared error represents where using the mean squared error as a scoring parameter. Then I'll set CV equals to 3. Okay. And I'll simply write as a like CV model, you can say. And if I simply call okay, params is not defined. Oh, I have to set the comma. Yeah. So this is the grid set CV I have. Okay. And these are all the values which I have passed here. Now CV equals to 3 basically represent 3 times we have to like do all the stuff. And okay, here we have a lot of values, so let me copy this one and I'll create few combinations only. Copy, paste, and let's create these two combinations only. Okay, yeah, so we will use this params as of now, this params grid. And now I'll simply write CV model dot fit, and I have to pass my training data set, let's train y train. Now you can see my model is like fitted. Like by mean how, like we can say for that we can use the verbose parameter like to see how it is working. So verbose parameter basically represents to show us the output like for each of the value. So there are various values for the verbose, like the computation time, the fold, and the guide. Okay, let me set verbose as 3. Now if I call the fit, you can see I am getting like a lot of output. What it is doing, it is showing, as I have set CV equals to 3, so it is like for each of the cross validation, like for 1 2 3, like first it is taking the squared error, and we have set I set CV equals to 3, so ये 3 times cross validation करेगा based on the squared error and this as the ETA value. Okay, सबसे पहले इसने इस पे किया, देन ETA हमारा सेम रहा एंड हबर लॉस पे किया, देन ETA हमारा 1 हो गया एंड इसने स्क्वायर एरर पे किया, एंड देन द लास्ट कॉम्बिनेशन. So this is how CV model is working, and then we can get the best values also. CV model dot best okay, best params. So by best params I'll get a dictionary of the best parameter value, whichever has the lowest score. Okay, so that will give us the best parameters. So this is how cross validation works. Aditya, is it clear?
Yes, thank you.
Okay, so the concept behind hyperparameter tuning is to find the best parameter for a model. Okay, um so this is the main all of the things. Okay, now should we move on to the mock, like the OPP mock? Just give a thumbs up like if like you all are clear. Okay, so for the mock I have already done the mock, so let me just open the notebooks here. Okay, so ओके, मॉक में आपको स्पेसिफिक किसी क्वेश्चन में डाउट है, और लाइक शुड वी गो स्टेप बाय स्टेप?
I had it out in second mock, last three questions.
Okay, first we will go from the first one.
Uh,
Sure.
Parampreet, is it possible you can solve the questions, all questions, if is it possible?
Yeah, it is possible. There is like no thing. Okay, let me simply edit it. Like, so the first thing first, basically, you have to import the required libraries. Okay, so we have two mocks. Okay, similarly we will get the OPP. First we have to do the data pre-processing in the first one, and in the second part we have to do the all the modeling stuff using the hyperparameter tuning and cross validation. Okay, What I have done here is I have downloaded the dataset, okay, from here, and I have imported it in my Kaggle notebook. Okay. So first I have imported the values, and then I have simply, like, I'm reading the dataset here using the pd.read csv, and the dataset name is preprocessing 3, so the first answer is obviously preprocessing 3. Then basic what you can do is, जब भी आप data load करो, as I told like earlier in my sessions, what you can do is you can look on the data, like using the data dot head and all. Okay, let me run that first. Session is starting.
Okay, let me estimate value.
Okay. So I have loaded the data here. Then the first 2-3 steps, what you can do is simply call the head function first, look at the data, then call the info function. Okay. Then look at the column values. You will get the idea, like whichever what columns have the missing values and what doesn't, which column does not. And then another, which is describe. These three functions you can call at first, okay, after loading the dataset. Then you will get a idea about your data set, whichever you are working on. So after that, like, we have a question, what are the unique values present in the locality feature? So we have a locality feature here, okay, and in locality feature we have various unique values. So I can simply pass in the locality feature in my data, and I'll have to call the unique, okay, unique function. It will give me the array of unique values, okay, and it is giving me Greenwich, Norfolk and all, and I am simply checking whichever option matches the value. So the second option is correct here. uh, do you guys have any doubt in this one, the second question? Okay. Then in the third is asking which of the following columns have categorical data. That you can check via this info method also. Whichever has the object value represents, they have the categorical columns. Okay, they are the categorical columns. Or what you can do is you can use this function select underscore d types and just pass include equals object represent the categorical values, and type in dot columns, okay, after calling this function, and you will get these um, object columns, okay, columns which have the object categorical data, and you can select based upon the options we have. And then it is asking which of the following features have missing values. Again, you can look in by using this data.info. um, we have like 10,000 rows, and whichever column has the less rows, that represent those column have missing value. So we have three columns: locality, estimated value, and carpet area, which contain missing values. We can check it via like uh, various methods. Okay, first we have to like replace the question marks also, so that we can replace using this. Okay, I'm replacing the question mark with the nan value itself. So then I'm simply calling is null or is na, both are same. I can call is na also. Then if I call the sum, I'll get the missing values, number of missing values in each column. Okay. Then in each column we get the missing values, and if we have to find total number of missing values, I can again call the dot sum. But here I have to like check which column has the missing values. So I can directly like check from here locality, estimated value, and the property and carpet area. This one step which I'm doing is I'm basically filtering all the, from this series of columns, I'm filtering whichever column has the missing values. So question 4 में किसी को कोई doubt?
What is ISNA?
ISNA, it is the same function as is null. It is NA or NA basically represent nan, right?
Okay.
So is NA or is nan, is NA or is null, both are same. Then question 5. Question 5, do you guys have any doubt? Like in the year 2022?
Shankar, can you mute yourself?
Sorry?
Okay, that was for Shankar, not for you.
Okay. Do you guys have any doubt in question 5 of the mock 1? Okay. In mock 1, which question do you guys have doubt? You can simply speak up or write it in the chat box. We will cover that one only. मॉक वन सबका क्लियर है? Okay, you can give a thumbs up, like then we can move ahead to the mock part 2 if the mock one is clear. Question 7. All right. Okay, so question 7, that is interesting. So this is the question 7. Question 7 is a little big, but don't worry. इसमें हमें करना क्या क्या है, we first have to replace the missing value, we have to check what are the missing values, then we have to replace missing values for different columns in a different manner. Like for the locality with the most frequent strategy, we can use the SimpleImputer directly for all these strategies. For the estimated value, median. For the carpet area, mean. And for the property, most frequent. Okay, so we have like 4 different things for, like, not 4, mainly 3 different things, and then like for these 4 features we can explicitly create 3 different imputers. All right. So here I have like done the same thing. I can also like I have created 4 different imputers. The first one is this most frequent for the locality, which is for this one. Okay, I'm replacing the nan values with the most frequent values. So I have set the strategy to most frequent and I'm passing the locality feature, and then for the estimated value strategy is median, and the same thing I'm passing here, the column I'm passing here mainly. And then for the SimpleImputer, then for the carpet area I'm using the strategy as mean, which is the default strategy, then again for the most frequent. So this is like the main code, and then I have one more parameter here, which is remainder is passed through, which basically gives us all the columns back. Okay, the transform columns as well as the original column. So if we run this column, if we run this column transformer, then we'll get something like this. Okay, this is the complete transformer, and after applying we have to like compute what is the mean. Okay, यहाँ पे हमें कुछ ऐसा specific करना नहीं, like we don't have to transform the data. What we are doing is we have to compute the missing, like the imputed values, right? So carpet area के लिए we have to compute the mean value. तो वो हम directly पहले भी कर सकते हैं, like same thing I have done here. I have selected the carpet area column and I have computed the mean, and as it is like written here up to 2-digit decimal places, so I'm just rounding it to 2 decimal places. So okay, it is giving the answer in 1. Okay, I have not created the data set mainly. So this is like how we have to do the question 7. Is it clear? Same thing for the rest of the values, just that वो question बड़ा है. आप like okay, I'll tell you a way कि like आपको ना ऐसे questions बड़े बड़े लगेंगे, like there is so much written, just ignore the rest of the things. First check the first line and then the second, then the third. Then जब भी आपको लगेगा कि यहाँ पे आपको कोड करना है, like for these 4 lines we have to write the code, right? Then एक एक line के लिए आप specific code करो, like for the missing values, like for the locality feature, first just simply copy this and copy this from here and simply in your collab, in the like the text, create a text cell and write the same thing. Okay, then आप इसके base पे like just read the line and do the code, एक एक करके do the code. Don't do like if you read all at once आपको थोड़ी confusion हो सकती है, तो ज़्यादा बड़ा लग सकता है, and you may like थोड़ा anxious हो सकते हो. So no need to worry, just एक एक करके देखो, बहुत simple है कुछ. There is nothing like difficult in the OPP. Then any other question in the mock one? Like we have 9 questions. Okay, so let's move on to the mock 2. Right. Okay, so in the mock 2, same thing I have done. I have like downloaded the dataset and imported it, okay, in my Kaggle notebook, and this is like how the data, like I am importing just pd.read csv, and I'm passing the dataset path. All right. So the first thing, and okay, before just like after doing anything, just read these instructions. It is saying basically split the dataset into training and test based on these things, okay, the provided values. The same thing I am doing here. Like first I'm extracting the x and y values, and then okay, after extracting the y and x values, I am splitting the training and test set based on the provided instructions. So in the mock 2, what like in which questions you have the doubt, you can like speak up or write it in the chat. We can discuss those questions. In like you can simply write or speak up.
So the second mock, last 3 questions,
Okay,
they
these
have asked is F regression score and all. We have to do a k-best feature. We have to select k-best. We have to apply select k-best here, right?
select, yeah, you have to apply select k-best and set k as 10 and pass on
Yeah.
this feature selection method.
Yeah. So what I did the same, but I am getting error that there are a few null or man values in the data.
All right, so it is like okay, so see, before doing that question, you have to
Hmm.
first do these previous questions also. So
Yeah, I
here
have done those.
okay, आपने सही data set use किया because this data set
Yeah,
is
yeah.
processed completely.
Yeah, exactly. That's what my question is. Ki if it is processed, why it is giving, it has nan values?
आपके data में like कोई just load the data set once again, upload the file
Yeah,
once again in your collab.
I did it once again. Maybe I need to download that once again because
Right, right.
I did whatever I had downloaded before 2 days. Maybe that dataset might have
Okay,
got changed. Let me check.
okay.
Thank
Shankar is asking, is this the correct code? Let me copy it. Okay, view or yeah. So in like question 5, we have to check in the year 2022, how many houses located in Greenwich locality have more than equal to 3 rooms and facing towards either north or east. All right. So okay, let me like split it in a way. So first it is like checking for the year, this is correct. Then the locality, this is also correct. Then the number of rooms, this is also correct. And then the okay, facing as north or east. Um, it looks like pretty much right. Okay, are you getting any error, Shankar?
No, I'm not getting any error.
Okay, is your code working fine or like The code looks.
Actually,
Mhm.
can you tell me what's the answer so that I can check? Actually, I have not submitted the mock. It for me answer is 35.
Okay, so yeah, answer is 35 only. I have also checked.
Okay, then it's correct.
Yeah,
Okay, okay.
it is correct. You have like अपने parenthesis का अच्छे से use किया, so there won't be any error mainly. Yeah. I have used the like the same way, nothing different. Just in a different format. Like I have converted the date into date time and use the Asian method rather than this built-in. We can do both these things. It doesn't matter. दोनों में same ही देगी, कोई different नहीं है.
ठीक
All right.
ठीक है. Thank you.
In mock 2, like, okay, I'll simply ask here. The second, third, and fourth question, are these questions clear in mock 2? If there's like, if the second, third, and fourth question are clear, just give me a thumbs up. Okay, how many of you have done the mock first? Like, you all can give a thumbs up or something like that. इससे मुझे clear हो जाएगा. Okay. So, सेकेंड, थर्ड और फोर्थ क्वेश्चन में किसी को कोई डाउट है इन द मॉक 2? All right. Then in the fifth question, do you guys have any doubt? Okay, guys, just either give a thumbs up or raise a hand so मुझे थोड़ा clear हो जाए.
I have doubt in fifth.
Fifth question. Okay.
I got a wrong answer.
What is the doubt?
I got a wrong answer.
Okay, wrong answer. आपने like, is this the code is same? Like, have you used the same code?
I am looking on my code.
What is your code? You can like just copy paste it in the chat.
Okay, okay.
For the fifth question, like they are asking to train the SGT regressor with these values and maximum passes as like 100. So maximum passes means the maximum iterations which we have to set, and then we have to
Okay, okay. That's why I mistake. Okay, okay.
yeah. Okay, all right. Okay. Then in sixth, seventh, or in sixth, seventh question, do you guys have any doubt? Just give a thumbs up if these questions are clear. Sixth and seventh of mock 2. Okay. So like before doing the 6 and 7 question, we have to do like check this. So we have to use a grid search CV on these parameters. So we have to use the polynomial features as well as our like transformer and the lasso as an estimator, and we can create a pipeline of it. The same thing like I'm doing here. First I have created a pipeline with polynomial transformation, like poly underscore trans as the polynomial features, and I have set interaction only as true. Okay, and I'm using lasso as a estimator, which is written here. Then for the grid search CV, I have to use the polynomial degree as 1 2, and then like the alpha values for the lasso estimator as these values, and these three things, the scoring, CV, and njobs, these are for the grid search CV. Okay, these are not the hyperparameters, only these two are hyperparameters. Okay, like how we have to write it, this is one way which we get confused. जो भी हमने name लिखा है ना, with whatever name we have passed in the pipeline, the same name first we have to write, and then we have to write double underscore, and after that the parameter name, like for the okay For the polynomial degree, to set the degree in polynomial features, we have the degree parameter. The same thing we are doing here. First we have, like, I have written the transformer name, like wherever I am using this polynomial features, I have written poly underscore transform, then double underscore, and then I have written like the degree here, which is basically representing for, which is basically working for this one. And then for the alpha, I have like the name for the lasso estimator as estimator, so that's why I'm using estimator, and then double underscore, then the alpha parameter, and then I have just simply passed on these values, and these directly in the grid search CV I have passed on the various parameters. I'm just simply calling the fit method. Okay. In mock 2, which question do you guys have doubt? Like, in any question you can ask. Okay. Is the mock 1 and mock 2 clear to you all? Just give a thumbs up, guys. So just
Can you discuss the 8th and 9th question also?
all right. So in 8th and 9th, okay, they are asking like further to reduce the number of dimensions of the training dataset with PCA. So PCA is a way of, like, PCA is a dimensionality reduction algorithm. It is basically to shorten the data set in the terms of columns. We can reduce the number of columns using PCA. Okay, so n components 13 represents to, like, to string the data set from the number of columns which we have to the 13 columns. So n underscore component represent that. Then SVD solver, it is like which solver which we have to use. The same thing, like I am passing here SVD solver, and then the white and also then the random state. These are the parameters which I have to pass directly, जो मेरे question में लिखे हैं. Okay, we can simply copy paste it and write it here. Okay, then the PCA is in the model selection, if I'm not wrong. No, sorry, PCA is in the decomposition library.
Yeah.
So from sklearn.decomposition, we can import the PCA, and then PCA maybe same thing we have to do. We have to call the fit function. Okay, PCA is like a model, you can say. Okay, don't use it as a transformer like fit underscore transform or something like that. Just use the fit. Okay, and then it will basically. Okay, like for the values, just call the fit, and like if you want to actually transform the dataset, then up fit underscore transform or fit transform करके separate भी use कर सकते हो. The same thing which I have done here. And then, like, they are asking what is the sum of explained variance ratio. Okay, so explained, like in PCA, as you all know, हमें variance मिलता है for all the features, and whichever features, like after decreasing those features into these components, we got various variance values. Okay, different variance values we got, and then it is asking like the sum of variance ratios. So उसके लिए ना, like what you can do is like to check the exact this parameter name. Like यहाँ पे हमें parameter name दिया हुआ explained variance ratio, but sometimes we don't have the exact parameter name in the question. What you can do is you can simply, like, if I import the PCA here from Sklearn dot decomposition, import PCA. So what you can simply do is okay, just write question mark and then the like whichever class you are using or the function you are using, and then you will get the signature of the complete, like the mainly the code part of the PC algorithm. Okay, with the documentation. So here you can see these, like the parameter represent the number of various parameters which we have. Then we have the attributes. So this is one of the attribute, explained variance ratio. In the attributes, you can see I have a components, I have a explained variance, and then I have a explained variance ratio also. Okay, so then I have also the singular values, the mean, n components and n features. These are the various parameters. So यहाँ पे हमें एक parameter का like sum निकालना है. So the same thing I am doing, like first I am extracting the parameter values, and then I just have to call the sum function. Okay, because it gives us the numpy array, and the sum will give us the sum, and I have to round it to 2 decimal places, and this thing I'm doing here, round, and in the brackets I'm passing 2. So this is the how we have to do the 8th question. And for the 9th, using PCA transform values. Okay, uh, we have to like transform the training and test dataset using the PCA. Then we have to like use the ridge CV. So ridge CV is using the ridge estimator. Okay, the ridge regression using the with the cross validation itself. Okay, so this is the same thing as using the grid search CV on the ridge. Okay, अगर आप grid search CV में ridge डालोगे, the same thing is like this. Okay, and उसमें हमें CV equals to 5 pass करना है, and alpha values is this, and that I have done here, and I have to simply call the fit. Then it is asking calculate the R2 score. So on R2 score, on the test dataset, I am calculating the R2 score and rounding it to 4 decimal places, and this is what R2 score I'm getting. So this is the main code. Is this clear? All right. Any other question in OPP mock 1 or mock 2? Like mock 1 part 1 or part 2? Do you guys have the doubt? All right. Yeah. Just like one thing. Okay. I have already shared these notebooks in the like in the group itself, but I'm sharing it here again, so you can like check the code, basically my code for the both of the OPP mocks. Okay, so I have shared it in the chat box and you can check them out. All right.
Can you share that py.main file also?
Main.py, don't worry,
Yes.
इसमें ये जो पूरा like this comment, I will share the exact copy paste in the group. Okay, after the session.
Okay, okay.
अभी
Thank
चैट
you.
में काफ़ी बड़ा हो जाएगा, so इसलिए I'm not sharing.
ठीक.
So do you guys have any other doubt in anything? Yes.
When other like parameter you used in hyper tuning lots of, if not given then we use default ones.
Right. अगर हमें कुछ भी नहीं दिया हुआ, then we don't have to do the hyperparameter tuning and we have to use the default values only.
Okay, and right. And second, in imputation part, KNN you explain little bit like how it work and what is. I know, but not so very clear.
Okay. I have explained like in the quiz one revision session also. I have told like I have explained the KNN imputer in the specific
Okay.
session, right?
Okay.
आप उसमें देख सकते हो like.
Okay. Okay. Which one revision?
Not in the quiz one revision. Let me share the video link.
Okay.
KNN imputer data preprocessing. Handling missing values. Yeah, first one, which is handling missing values. In the handling missing values, I have explained the KNN imputer. If the NaN, if the maybe, I think like यही कहीं पे I have explained. So आप एक बार like you can check this out. All right, and
Okay.
then आपको idea मिल जाएगा. Let me share the video link.
Timing is like, what is the time between?
Sorry.
Time, can you tell me the
Yeah, time
time?
also I have like time is also there in the video. like you can
Okay.
check the chapters in the video description. Okay.
Okay. Okay.
तो
Okay.
वहाँ पे आपको मिल जाएगा, right?
Okay. Thank you. Thank you.
Fit and fit transform. See, fit you have to like use whenever you have to compute the values. Okay. जब आपको सिर्फ values compute करनी है, then just simply call the fit function on the training data set. Okay, fit always call the first and the second on training data set only. Validation or test data set पे you have to call the transform function only, not any other. Okay. And fit transform basically transform those the data set using those values. No, you have to like pass any one of them with minimum of 40 marks. All right, so do you guys have any other doubt?
बट मार्क्स तो दोनों के कंबाइन होंगे ना क्विज की तरह.
Yes, mainly one is necessary. Like
Yeah.
similarly we have quiz, no, one is
Right. Right.
important for income, same thing.
Right.
All right, so like should we conclude our session? Yes, it is recorded. Yeah. Okay, so let's end the session. I hope like you all have learned something and आपके OPP की revision थोड़ी अच्छी हुई होगी. So that's it for the